Welcome to the training, Digital Twins Generation and Enrichment in Buildspace Pilots. My name is Lizeth Lopez. I'm a project manager at the Environmental Climate Hub and ALDA, which is the European Association for Local Democracy, and I will be your moderator today. The final goal of today's event is to introduce you to an overview of Buildspace background, objectives, and the potential for replicating its methods across Europe. This session will specifically present the features of the Buildspace pilots in Poland, focusing on the technologies used in the development of Service 1, Digital Twin Generation, and Service 2, Digital Twin Enrichment. So now let's have a look at our agenda for today. We will begin with an introduction to the Warsaw and Poznan pilots, followed by an explanation on the data collection technologies. Then we will go to have a more detailed look into the applications of Service 1, which is generation, and Service 2, which is enrichment. We will have a few discussions regarding the replication success, the strategies, and how we can expand these services into other territories. And then we will do a live demonstration, which our service developers are going to take us into the service itself to see the integration and analysis of both services. At the end, we will have a short session of questions and answers in which we kindly invite you to send us your questions throughout the webinar. We will be collecting them. Or, as I mentioned earlier, you can raise your hand and we will give you the access to interact directly with the panelists and explain your questions or your doubts in a more detailed manner. Then we will finalize this session with some key takeaways and some action points which you can do to keep in touch with not only Service 1 and Service 2, but also with the Buildspace project. So before we go into depth into these two services, I just want to give you a brief overview of what Buildspace is, which is, of course, the framework in which these two services were developed. So Buildspace is a 3-year project which supports the Green Deal objectives. We are a consortium of over 14 partners in Europe. The goal of the Buildspace project is to couple territorial data from buildings with aerial imaging from drones equipped with thermal cameras and location annotated data from satellite services using different types of information. This is a Horizon project. We have a budget of over 2 million and the time frame is from 2023 till 2026. So the project at the moment is its final year. Then Buildspace platform, which is the final output of this, the Buildspace project, will allow the integration of this heterogeneous data and will offer 5 decision support tools applied from building to urban scale for key stakeholders in the construction and renovation sector, for urban planners, city authorities, NGOs, small, medium-sized enterprises in the space, building, and energy industry, as well as policymakers and researchers. Specifically today, we're going to see 2 services at the building scale. So why are the Buildspace relevant? Because urban areas face climate challenges that we need to know how to tackle, and these decisions must be done by very informative and accurate information with tools that have been developed out of especially aware and scalable data. Buildspace also delivers tools that integrate Earth observation and AI to support cities and stakeholders, as our service providers will explain later today. So, without going more in depth into this, I would like to introduce our 3 distinguished speakers whose expertise bring together research, industry, innovation, and digital transformation in the construction and urban resilience sectors. So first, I would like to welcome Witold, who is an innovation specialist at Mostostal Warszawa, one of the Poland's leading construction companies. His work focuses on digital building permits, drones, laser scanning, and carbon footprint management in construction. Mostostal also plays a key role in spreading open BIM standards through its digital transformation department. So very welcome, Witold. Then we have Dr. Yawen. She's a postdoctoral researcher at the University of Cambridge, where she leads Buildspace research on AI and machine learning for automated digital twin generation from building point clouds. Her work also explores the use of linked data and large language models in construction technology. So thank you, Vijay, for being here as well. And our third speaker is Rubén Santamaría Maestro, who is a predoctoral researcher at the Universidad Politécnica de Madrid, specializing in geomatics, laser scanning, photogrammetry, and AI applications in the built environment. The Universidad Politécnica de Madrid is Spain's largest technological university and a leader in applied research and innovation. So with this big introduction, I think we're in really good hands for today. And for now, this is all for me. And without further ado, I will give the floor to Vital, who will walk us through the pilots of Warsaw and Poznan. Vital, the floor is yours.
Thank you very much, Lisa. Thank you for this introduction. I'll just ask if you can already see my screen.
Yes, we can.
Perfect. So in this panel, I will explain what ambition as a construction company we had within the Buildspace project, what we wanted to achieve, and how this builds value for us as a Polish construction company. I will also introduce you to Warsaw and Poznan pilots. Here I'll just give the basic information about two construction sites that we used for data collection and then later testing of the services developed within Buildspace. And I'll mention quickly which use cases we tested at which construction site. There will be a lot of switching between those two sites in Warsaw and Poznan today. So our first ambition was the automated creation of digital twins from point clouds. So here as a digital twin, it's important for us to have not only point clouds, but to consider digital twin as a BIM model. So within a BIM model, we have an opportunity to have way more structured data than in a point cloud. And although point clouds are good for some use cases, the BIM model will always be something that people can open freely and browse the information. So simply in our industry, people are more used to BIM models. And oftentimes, whenever we start a new construction site, we are replicating some existing objects manually, and this meticulous work, it always takes a lot of time. Creation of BIM models takes a lot of time, so there's always room for automation here. Another ambition of ours, so as a construction company, what our main field of work is managing and monitoring and steering the construction process. So naturally, we also look for chances to automate the monitoring of the construction process. And here, especially, we focused on utilizing regular drone flights for monitoring deviations. So we wanted to have information about the deviations to collect the data with drones and then have it parameterized, saved for viewing in a BIM model. Once we are finalizing our construction process and we are handing over the buildings to the investor, it's often that we are asked to do a thermal assessment of the facade to show that everything has been executed according to the design plans. At times also you might need to do an analysis of thermal bridges and thermal anomalies before you even start the construction site. So within Buildspace, we also looked to create reports automatically from after conducting a drone inspection. And as well, oftentimes we build for the public use, and in those buildings, oftentimes there is a photovoltaic installation. So we also wanted to have a functionality of assessing the panel cells performance. So this allows us to check that nothing is damaged and that everything was installed correctly. Just another way of quality control. And in our research and efforts, we also often look for an opportunity to interact with the mixed reality interfaces. So within Buildspace, we also wanted to have a chance to browse some of the data collected in the mixed reality interface. So if you, as you may have already realized by the images in previous slides, we managed to, in some shape or form, execute all of those ambitions and realize them within our Buildspace services. And for data collection and when testing of those services, we used 2 pilot sites. So not all of you have to be familiar with the geography of Poland. Here you have a simplified map of Poland with Warsaw, the capital, marked, and Poznań, another big city in Poland. And we used 2 of our construction sites, the Rectorate building for Poznań University of Technology, and we are also building a new faculty of psychology for University of Warsaw. So here I'll quickly go through some more information about those sites. So the Poznań building, during the execution of our task within Buildspace, this construction site was ongoing. It is still ongoing. This was needed for us because we wanted to monitor the construction of the load-bearing structures. So we wanted to start data collection from the construction of the foundation of this building. And its use is we're building it for a university. It's going to be an administrative building. It has 4 above ground stories, 1 underground, with approximately 6,000 square meters of usable area. And some worth mentioning features are the fact that this building is designed as a nearly zero energy building. And it also has geothermal installation as well as photovoltaic panels on the rooftop. The Warsaw pilot is right now undergoing the final handovers. So this construction site started way earlier than the Poznań one. That's why we couldn't use it for all of our use cases within Buildspace project. And again, we're building this faculty for University of Warsaw. This one won't be strictly an administrative, but an educational building. So the students will hopefully soon be visiting this faculty every day. And this building is of much bigger scale. It has approximately 21,000 square meters of usable floor area, and it has also a strong focus on sustainability with achieving BREEAM certification. It also has a photovoltaic panels on the rooftop, but you aren't as interested as for the building and its characteristics, but more about the use cases that we used those construction sites within Buildspace. So here in Warsaw, we focused on the digital twin generation. So here we had more detailed drone missions and data collection, which allowed for the generation of the facade geometry from the point cloud data. And here as well, we had within the service tool the thermal quality control of the facade. Simply on the other construction site, we didn't have the facade constructed yet once we were conducting the drone flights. In the Poznan pilot, we dove into the delay detection use case. Let me now switch presentations and we'll go through to the key concepts of Buildspace. So I'll stop sharing for a second. And please let me know if you can now see the beginning of the next.
Yes, we can.
Perfect. Thank you, Lisa. All right. So here, no worries. It won't be just me speaking in a second. So in the key concepts, it will be me and then Ruben going through the main technologies and such that we used for our two Polish pilots, and then Ruben together with Ja will dive into the services, and then we'll go to the demo session. So the key concepts. And before that, I just also wanted for context to mention that we had service 1 and 2 implemented at our two construction sites, but Buildspace goes more broadly in its innovations, and there are also within our project other pilot sites that had also city-level innovations. Today we will focus only on the building level ones. So firstly, we mentioned digital twin, and it's always such a problematic thing to define how what it's hidden behind this term digital twin. I don't think there are two researchers, two engineers who have the exact same definition of this, but well, generally speaking, it should be a dynamic virtual representation of a building asset, and it should be valid across its life cycle. So starting from the beginning of the building's life to its end, we want to contain some information in it. And you can include real-time data and others, but the digital twin also has to be fit for purpose. So of course, for instance, for our use cases, we didn't need to implement any real-time sensors. We mostly focused on parameterizing building information within our digital twins collected with drones and laser scanning. So let's move on to the next term. I won't be defining what drones are. I think we are all aware of different uses of drones, but within Buildspace, we had 15 individual drone missions for 2 Polish sites, and we used different drones with different purposes. So we used a drone that just took pictures for both Warsaw and Poznań pilots. And thanks to the photogrammetry, we were then able to create point clouds from those pictures. In the Warsaw pilot, we also had the thermal analysis. So naturally, that's another drone which took simultaneously visible light and thermal pictures. And in Poznań pilot, we didn't have to do this, but we also explored creating point clouds directly. So not with pictures, but with direct measurements with a drone that was equipped in a LiDAR sensor. So I mentioned photogrammetry. I think it's a key concept for the data collection for our pilots. And photogrammetry, simply said, is using drones to take many overlapping photos of an area or a whole building. That then can be processed to achieve 2D orthophotos or in this project, especially 3D models such as point clouds and meshes. And here you can also see some of the routes that a drone had to take at our Warsaw site to take pictures of the facades. So you can fly in many different ways. You can fly in a constant above ground height, but to have a very detailed photogrammetric data of buildings' facades, it's also good to fly in vertical to the facades. Yeah, there's a lot of software that allows you to create point clouds from the photogrammetric missions. We also use for the inventorization of the internal part of the building. It's quite hard to fly drones there. Laser scanning. So at Warsaw site, we have scanned the complete building, and for this we used a Leica scanner. This takes much longer than a typical drone flight, but thanks to simultaneous localization and mapping, you not only immediately can view the scanned area, but the stations from which you move the scanner are visible and mapped in the point cloud. So you can, during the process of scanning, control and monitor what you are scanning and what information you managed to already capture. And now to mention the scope of exact data collection at our sites. So in Poznań, here again the use case to detect delays, we did 11 drone flights that were spread out. So we did them in 2 or 3 weeks intervals on average. And we did that to then from each point cloud have particular stages of the construction to monitor the construction process. So here the drone flights had to be perfectly matched to the construction process to not miss any data. And in Warsaw Pilot, we had 4 total drone flights. I will immediately say that it wasn't necessary to have exactly 4 of those, but maybe to keep some suspense, I'll later in today's event explain why we had to do 3 total thermal missions. And as I mentioned, we also did an internal scan of the complete building. This was a major effort spread through, I believe, 2 months of work, and we created almost 1,800 individual scans, which were then connected and processed, and this way we produced almost 300 gigabytes of point cloud data. Now I'll give floor to Ruben to go on with the key concepts related to building inspection.
Thanks, Wito. So basically, I will be diving through the key concept from the Service 2 side, which has been tested on the Warsaw pilot. So starting with the concept of the thermal envelope. Well, this will be a concept that we'll be referring frequently throughout all these sessions. And the thermal envelope includes all the elements that separate the interior environment of the building from the outside, let's say walls, windows, floors, and so on. So its main function is to regulate heat flow, helping to keep the building warm in winter and cool in summer. So in that sense, a well-designed envelope is essential for energy efficiency and, of course, indoor comfort of the inhabitants. Then, if you can move, Wito. Moving on to thermal anomalies, these are areas of the envelope that behave differently in terms of heat transfer of the building. So a common example would be a thermal breach, which is a place where heat escapes more easily than it should. And this typically happens at corners, structural junctions, or weak insulation points. So in that sense, these, no. Could you please come back just for a second? Okay, in that sense, these issues not only reduce comfort, but also they increase energy loss in both summer and winter. To detect these anomalies, we use thermal cameras, which are devices that convert infrared radiation into temperature images, which allow us to visualize heat patterns on a building surface. That way, we can identify issues like heat leaks, moisture, or poor insulation, even if they are invisible to the naked eye, which is most likely the case. Traditionally, this inspection is done with handheld cameras, requiring a technician to walk around the building and manually capture images, which has several limitations, ranging from lacking access to harder to reach areas to relying heavily on the operator's experience. So on top of that, the images are not integrated into any 3D model, making the process slow and subjective. To overcome these limitations, we use drones equipped with dual cameras, as the 2 images we may find on the right side, to inspect the entire building's envelope, including these roofs and facade that are hard to access. So these drones simultaneously capture both RGB images, which show true RGB color, and thermal images, which highlight temperature differences, all in one flight at the same time. So while drones improve access and coverage, they still don't solve the core problem we're saying, which is that images are still isolated. So they are not geometrically aligned, and the facade analysis often still relies on handheld inspection. So we are still lacking a truly integrated view of the building's envelope. To solve this, the RGB images are processed using photogrammetry techniques, as Wito was saying, mostly relying on extractor from motion and multi-view stereo techniques to generate a dense 3D point cloud. And then, thanks to the algorithms developed within the Buildspace project, we are able to include thermal data from these thermal images into each point of the cloud. So the point will not only contain geometric data, but it will also contain thermal insights of the building's envelope, resulting in a layered and detailed digital model of the building's characteristics, both visually and thermally. So I think that beyond from the key concepts we will be needing. And now I'm letting you, I think, yeah, you got the one.
Thank you, Ben. Thank you, Vito.
Welcome.
I'm not sharing my screen. Can you see the screen?
Yes, we can.
Okay. I'm Yao. I'm very happy to be here and to share from the service provider side. I will introduce the service one part, which have two pilots. And in the service two, Ruben will introduce later. In each service, we have these three points of introduction. First is objectives and input data and processing, and the methodology of it, and the platform functionalities. And then I will talk about the service one and service two synergies. So here, just give an overview of what we are doing. From the data capture part, we have the drone and laser scanner. Vito and Ruben has introduced much on this, and the processing. So when we are mainly process the 3D point cloud model, and then we have the results for the service one. We have the IFC generation part, and also we have the construction progress monitoring part. Here is in Warsaw pilots, and here is in Poznan pilot. And in service two, which is in Warsaw pilot, we have the thermal anomalous detection, crack detection, solar panel detection, and repulse. And for both services, we have our visualization tool. We also integrate our service into one platform, and it will be and it already be integrated to the project, which is Buildspace project core platform. So here is the objectives of service one. We focus on the automate the 3D geometric digital twin generation from the UAV and SLAM data, which is the point cloud data generated from the images and LiDAR point clouds. We integrate the eGNSS data for the high accuracy geolocation. Here you can see we put our projects in this GIS map. In another testing, we also work on the data updates part for the construction phase. So for example, here you can see we can visualize it in a geo map. And then we, for this digital twin in construction phase, we also tested the AR visualization method on the construction site. Except for this pilot, the pilots in Poland, we also have three pilots, which including three buildings. Here you can also find the demo link I shared, Lizette will share later. You can also see some information about the other pilots, but we will not cover it today. So I will go for the first, the digital twin generation part. So here from the objectives, we are going to do geometric information, which is the geometric digital twin. And the key part will be extra the key information, the key geometric information from the unstructured point. So our input data will be the 3D point cloud data E57 or LAS format. And in the processing part, we segment our point cloud data into wall, windows, door openings, and roof. And we extract the boundary of this and for users to measure and also see what the semantic information linked with the digital twin, and to retrieve the special relationship information among different elements. So here is the input and processing. So here is the two pilots. For these pilots, as I said, we have the data. We need to do the data generation, data clean segmentation, geometric extraction, and FC generation. And for the updates, which is the construction part, we have the method we are doing is to coordinate between the point cloud data and also the FC data, and code the points in the boundaries of each elements. And then we do the inference for the construction progress and then visualize it. Dig into the first generation part. Here we have the detailed methodology here. The first step we are doing is we need to clean, right? Because the model we have is have many noise, but we only want the primary building elements like wall, roofs, openings on it. And after we get the cleaned point cloud data, we use machine learning algorithm. Here we use 0.9 and ++, and we also tried another algorithm that is not work that well. So 0.9 ++ works okay for this case. And also plus some manual adjustment, we have the segmented point cloud data. And for the segmented point cloud data, we have the separate categories, which is roof, wall, and window. And then we extract the geometric information on it and then show it in the platform. Oh, sorry. Okay, so here is the visualization in the GIS-map shows at the left-hand side, we have the geolocation of this project. And then we have the integrated viewer, and also we can call it the visualization for the federated model, because here you can see we have the point cloud data, we also have the FC data. You can access to the FC information here. And also in this viewer, we have the function. We have this several functionalities. In the later demo phase, I will also show these functions as well. So here, for example, you can see the segment building elements here. And I also mark up the different categories of the points into different colors. We can have the section box to see what's inside or the section of this whole building. And we can do the measurements. We can visualize the elements properties where you clicked on the FC elements. And we also can set the transparency of different elements, no matter it is FC model or point cloud model. So let's move on to the second pilot, which is where is in Poznan University of Technology. Here we have this building already introduced by Vito, and in this case we mainly detect elements is the structure elements. In the here, what we also have to prepare is the FC as designed information, which is as designed FC model. In each elements, we need to have a proper GeoID, the global ID, to trace the information of each elements. And for the preparation, we also need to have the schedule data here. It shows the schedule finish date, schedule start date, which for us to retrieve the information. So our core methodology is to compare each scans with the as designed model. Here I have the detailed process, like what we should extract from the FC model. We need to have the task ID, task name, GeoID, the boundary box with the geometric information of each element, and also its related schedule date. And then we extract the task and to filter it according to different complete date, because we need to detect the delay elements. So we have to do this several times, and then to make sure it is in the same coordination, and so we have the threshold verification of it. And then we update according to if there is a 0 point or less point or many point, thousands of point in some in the box. So we can infer like if this object are constructed or not, and then compare to the scan date, which is the what date belongs to this point cloud data. We update the status, and then we highlight the delay elements and put the attributes in it in the FC model, so that the FC model can be updated. Actually, during this this development, we find there are some errors, which is although the object is already built, but it's occluded by the other elements. So here's our conference paper where I developed from here, and to have the visual language model orientated occlusion and analysis. It already be published and open online. So if you are interested, you can go and find the paper. For the visualization part, we have the Poznan location of it, and we also have different model linked to this GIS location, which are the as designed bit model, the updated bit model, and the federated model coordinate with each point cloud data, and also the updated FC model. Also, we put it in the construction site. We use the AR tool to test if it is work well. And the results that we can see the attributes on site coordinate with the actual construction site. And we will also cover this part in the later demo. Okay, so Ruben, yeah, that's all for me. So Ruben will talk about the service tool.
Thank you so much. So I might start sharing my screen. Okay. So this section introduces the service to insights, which is the model developed by the framework of the Universidad Politécnica de Madrid. And we were aiming to rethink the way we perform thermal analysis of buildings. So in that sense, we started with a simple but important question, which is, could we buy a 3D dimensional thermal representation that is accurate enough to support real-world energy retrofit decisions? And in that sense, it was developed, this whole service to address this challenge, which aims to integrate thermal and RGB imagery collected from drones and handheld devices. So with all this data, we can detect thermal anomalies like cracks, thermal bridges, humidity, and also malfunctioning solar panels. The system then combines UAV photogrammetry, as we were talking before, for capturing the building's exterior with slant-based scanning for its interior, giving us a comprehensive view of both the building's exterior and interior faces. So in that sense, all the data is brought together within a 3D viewer, which has been developed from scratch, including tools for classification, measurement, and also annotation, allowing users to explore and analyze the building in detail. The solution has already been tested in Madrid, and then the whole pipeline has been deployed into Piraeus and Poland pilots. On the right side of the slide, you can see the user's interface of the platform, showing how the enriched digital twin looks and how users can interact with it. So regarding the input data and processing, so we first start with three main sources of input data, which are the RGB and thermal images captured by the drones equipped with dual cameras. Then we get the indoor point clouds obtained with SLAM-based mobile mapping systems. And third, we include GNSS control points for accurate georeferencing of the 3D model generated. Once this input is collected, the processing stage begins, which involves three key steps. Joint calibration of the RGB and thermal cameras to ensure both types are perfectly aligned. Then data fusion techniques, which are used to generate the combined RGB and thermal 3D point cloud. And finally, we introduce AI-based analysis for automatic detection of thermal anomalies present in the envelope of the building. Now we'll walk through the methodology used in this service, as shown in the diagram, which is a multi-source, multi-layer process that ensures that the digital twin is not only rich in geometric, but also rich in semantics and thermal insights. In that sense, here we can see the equipment used to carry out the data capture phase. At the top left, we have a DJI drone, a Mavic 3 thermal, which is equipped with these both RGB cameras and thermal cameras. And on the right side, we have a close-up on the camera with both sensors mounted together. Then in the bottom section, we have the device used for interior scanning, a handheld SLAM system, which uses simultaneous localization and mapping to build the 3D model of the indoor environment of the building. So this slide shows the data capture process in action, along with some valuable insights from the drone pilot. The drone is flying over the building to capture both RGB and thermal images. And well, it's also important to note that this process is quite difficult, that as Whittle was saying, that it required a close collaboration in between the service provider and the pilots, so as to ensure the quality and consistency of the data. In that sense, as a result, we developed a step-by-step data capture guide, which is helping us standardize the procedure and improve the reliability of the collected images. Then once data is captured, it goes through a series of processing steps to generate the final 3D model. So this slide illustrates the calibration process, which is essential for aligning these RGB and thermal images. On the right, we can see a chessboard pattern being used during the calibration session. And this calibration mesh was built by the pilot, following the provided guidelines, which were specially designed to having a mesh visible in both RGB and thermal spectra. So in short, this step ensures that thermal data can be reliably mapped onto the geometry of the building, supporting either precise anomaly detection in the next stages and precise 3D reconstruction of the whole building. So this would be the software that was used to carry out the calibration process, either the RGB and the thermal images to estimate their camera parameters. So on the left, we can see the calibration interface. And on the right, we have a pair of images taken from the same building facade. So we can see the distortion applied to correct both of them. Then once all the data has been calibrated, we are able to generate a dense 3D point cloud from the RGB images that accurately represents the geometry and textures of the building's exterior. To achieve this, as I said previously, we follow a standard photogrammetric approach with SFM and MBS techniques. And as you can see in the image, the model captures fine details and realistic textures of the whole building's envelope, including windows, roof elements, and surrounding areas, and serves as the geometrical and visual foundation of the digital twin, onto which we will be able to add different layers, such as the thermal and the semantic information ones. Then we are able to project the thermal information onto the point cloud, which is the read from these thermal images we have already corrected. And this model complements the RGB point cloud, adding temperature information to each of the points within the 3D point cloud. That way, each point of the point cloud not only has a spatial position, but also a thermal value associated with it. Then, as you can see in the image, thermal intensity is color-coded, with warmer areas shown in yellow and orange, and cooler areas in purple and blue tones. So by combining this thermal point cloud with the RGB model, we are able to create a fully enriched 3D representation of the building, which was one of the main goals. Then we get the interior RGB point cloud to complete the digital twin, as shown in this slide, that was obtained from the SLAM techniques. And as shown in this slide, we are able to achieve the final point cloud, which combines all the data capture throughout the workflow. So here we have the RGB exterior with the RGB interior and the thermal envelope of the building, all into a single unified 3D model. Then we conduct a classification phase, which allows us to provide semantic labels to the different surfaces and elements within the building, which are the foundation for the thermal anomalies detection phase, which is based on statistical algorithms that analyze temperature variations across the different building's envelope elements, allowing us to visually and spatially identify the thermal anomalies present in the building's envelope. This would be a close-up view, focusing on the solar panels and the malfunction detected, and as well as some regarding the facade. Then all these anomalies detected are, to conclude with the methodology, are included into an automated report that is generated based on this detection. So it provides a structured summary of the detected issues, and it is designed to support building diagnostics and decision making. In that sense, as shown in this slide, each report includes a global view of the building, then a detailed view, either in RGB, in thermal, and in the detection layer, and also a summary table that focuses on each of the parts of each facade. And then it lists each anomaly with different concepts like mean temperature, anomaly temperature, and the estimated deviation from the mean temperature. So this would be the research that has been conducted that shows how it is technically possible to create a thermal 3D model of the buildings using drone flights, as we are saying at the beginning of this session, and more importantly, that we can detect and classify the thermal anomalies directly on this model. Well, in terms of visualization, additionally to the service development, a 2D and 3D geoportal was developed from scratch to support the full interaction with the Service 2 results. And in that sense, to wrap up, we take a step back and look onto the core service objectives. We can see that the platform has been built around these core objectives, and ultimately it supports stakeholders in making informed decisions. So in this way, it bridges the gap between raw sensor data and decision making, offering a user-friendly interface that translates technical data into actionable insights. So regarding these key features, we have two main views. The first one would be the one on the top, which is the pilot map navigation. And it allows the users to explore the pilot buildings all across Europe that have been tested either on the Service 1 or in the Service 2 pilots. And it also includes brief insights on the building's characteristics and a shortcut to the either Service 1 or Service 2 links. Then on the bottom part, we have the 3D viewer interface, which allows the user to explore either the RGB, the thermal, and the semantic 3D point cloud, and toggle between them using different analysis tools, and being able also to turn in and off the different classification layers so as to focus the view. And I think, also the different tools that are placed on the top toolbar are range from measurement and inspection tools to gaining access to these automated reports we were saying previously. And that will be, we'll dive into all these platforms further once we get to the demo session. But this would be most likely all the insights from the service too, I think. So I think you can now regain control, yeah?
Yes. Sharing my PowerPoint. Can you see the screen now? Okay.
Yes.
So yeah, after introduce our services, I just bring this slides out again, just to emphasize that our services covered from processing the point cloud data, the image, and also we have the FC data and the construction progress monitoring, and also thermal information for the many users and can explore based on our outcomes, and it benefits a lot of people. For example, we have for the synergies and usability of Service 1 and Service 2, we have the seamless transition from the point cloud data into the FC data. And the FC data is widely used by many functions and by many users, and it can be continuously put more information in it. And we have our platform, which is provide the opportunities for the further users, and we have the demos that how we use this information exactly. And for the thermal perspective, and also for the visualization perspective, the facility managers can actually see the what is the information that cannot see from eyes, but we have the technology to visualize it and to further plan their works. And then we have the life cycle value, because we capture our existing data, and also we visualize the digital twin and point cloud and thermal in one go. And if we put more information, it can create more value on it. So for the opportunities for replication, if other parties also want to process through this, we have some we need to meet some requirements except for the required data. And also the coordination between the different parties. For example, for the service one, which is very important, is we need to have the high density point cloud data, and also the drone image if we want to collect the information. And in the point cloud segmentation phase, actually, we had some problems to accurately segment the building wall openings and the roof. The reason is that we lack of our training data set with the same building style and the same data source. Actually, if your data source is from drones or is from the laser scanner of, for example, airborne laser scanner, the resolution is quite different. And we also need for the digital twin updates palettes if we want to update the schedule information, the construction progress information of it, we need to have the schedule information to process and to infer for the next step. And Ruben, if you want to
yeah,
talk
sure.
this.
Thanks. So discussing the replicability of the service 2, we are referring to the key conditions that we require to successfully apply this methodology in other locations. So beginning with the general criteria, we are looking for urban areas, most likely not city centers, so as to easily comply with the flight regulations. And then we would require a public building with easy access, let's say a school, a clinic, a library, that ideally it should be isolated or located within a block that has mostly visible facades, having in between 4 to 7 floors preferred. And then we also need to avoid some physical obstacles near the facade, like having vegetation close to the building, hanging cables, and roof antennas, in example. From the thermal imaging perspective, we would prioritize urban streets with little to no vegetation as well, since these green areas interfere with the thermal data. And then open squares, even with just a single exposed facade, are also very useful as they improve visibility and data quality. So we try to avoid buildings close to parks, as they make also thermal comparisons less reliable. And of course, once again, we avoid restricted flight zones to ensure legal and safe operations within the flight regulations. And that be all.
To continue on the topic of replicability from the pilot owner's perspective, in Poznań, we conducted 11 drone flights, but to be honest, for this surface to work, you must perfectly match the construction steps with the drone flight dates. So, for instance, to have the columns of a certain floor captured on the pictures, we had to make sure that before the slab of the next floor is constructed, we have to quickly have the drone mission, and this is very time sensitive. So to have something similar done at your construction site, it would be recommended to have both a pilot and a drone available at all times on site. And of course, even before you consider replicating this use case, check formal requirements for the drone missions. So not only in different countries, the certifications that pilots have to have vary, but also there are geographical zones that may completely disallow any drone missions. So, for instance, if you would move our Warsaw pilot just a few kilometers north, it would be so close to the city center where there is a military zone that it would absolutely disallow any flying of drones. So this whole use case would be impossible. But commenting on the results of the Poznan pilot, the results, they weren't perfect because we haven't perfectly matched the construction steps with the drone flights, but still the parameterized model, the element status is easily viewable in both the desktop interface as well as in augmented reality interface. So we are very satisfied with that, and you can say it worked. The only thing is that in the research project, we had a big time gap between the data collection and the surface testing. So naturally, it would make more sense to immediately after a drone flight process the information and have it viewable at the construction site, because later on it kind of loses the purpose. Nonetheless, we are very satisfied with those results. So we can move on to the challenges at the Warsaw pilot. And I think now I can let you on the secret why we had 3 thermal missions that were spread out over a longer period of time than a year. You need very, very, very specific weather conditions to carry out the drone inspection. So we discussed this on many calls with UPM team. It was a challenge. We are getting frustrated at certain points because you would think that Poland has a very cold weather, but it was very hard to, in the winter season, find a day of weather where you would check all the conditions. So for the thermal drone flight to work, it has to be a bit cloudy because you cannot have direct sunlight. You can't also do it during the night because you need the visible light, so RGB pictures to be taken and to collect that information as well. There has to be a difference between the temperatures on the outside, so the weather temperature, and the inside of the building. You also don't heat the construction site at all times. You don't have perfect 20 degrees temperature in a construction site. So we did 2 flights where we also took too many pictures, and they were very hard to process, and the weather conditions were simply not good enough. So 3rd time was the charm in this case. And we managed to do that. And as well here, of course, for the thermal inspection, you also need to be able to fly a drone in your area. And even if you reduce the number of pictures taken and so on, the point clouds will still be huge files. So you have to have technical infrastructure to your computer servers to handle that. In this pilot, we not only carried out the drone flights, but also the scanning. And this is just a huge effort, which took a long time. So you have to also have resources for this. But yeah, thanks to all of the data capture, we managed to have the beam elements automatically generated thanks to Surface One. So this may bring in value to many projects. And the thermal inspections, it has a lot of information that could be helpful for a handover during meetings with the investors. So it's very valuable information that we received. great that we have all of those functionalities integrated in one platform. So perhaps we can now move on to the demo session.
Yeah, thank you, Vito. So here we come to the demo session. I will put one video here, and you can also scan this QR code to access to the model. And I think Lizette will also send the link in the chat, and you can open it on you open it in the website in your computer. If you have it shows like access denied, but if you refresh the page, it will goes fine. So here I will talk along with this video. Here you will see the visualization of the federated model, which point cloud and data and point cloud and digital twin. If you click the points, you can see the raw point cloud data, and you can select this click here to hide it, and then you will find the segmented elements of this point cloud data, the wall, windows, and roofs. And then, for example, here, if you click the one element and if you go to this button, it can directly link you to the list of here, and then you can set the visibility of this element. Yeah, after you hide this part, you will see the windows of it. Yeah, and here is showing the segmented, the classified point cloud data with different colors. If we hide it again, it will show the single windows. And if we go to the FC model, to visualize the FC model, we can select the single walls. And we can also visualize our opening elements, which is the windows of it. If we had this wall, and here we can visualize the relationship between the openings and the wall. If you check the probability of the window, and you will see the elements, the associated wall here, and it will link you to highlight the wall. If you go here and you hide this wall, and then you can see the overlap, the coordination between the point cloud model and also the digital twin elements. We can select the visibility of single elements. You can also set the transparency here. And with this digital twin model, we can extract the age of the point cloud. So we can have a measurement, for example, the width of the building and also the height of the building. And also if we click here, we can measure the area of it. We can also go to the section box. We can see the sections from different directions, and you can also adjust the angle. And you can adjust from the different directions, show it or not. Yeah, and we can also go with the game mode. If we go with the first person navigate, we can use WASD in the keyboard to lead you to the outside or inside of the buildings. And in here, you can navigate along the building and also set the visibility if your click go when you go around of it. Yeah, I think that's all for the generation part. Let's go to the second. So this is the other pillars of service one, which is the digital twin updates in Postnet. Here, I will introduce a four part, but I will enter from this website, which is the GISMap, and in this part, actually, it links to the three models, and this model actually also includes the updated digital twin model. So I will start here. From this GISMap link, you can go to fly to the Postnet location. If we click it and we go to the document button, we will see the geolocation. But if you go to the linked documents link, you will see the three link documents are associated with this page. For here, I will just quickly show like what is inside. And then for the federated model, we will, because this is very important for us to investigate if that's correct by combine different scans of the model. So because of the size, the file size, I put the three scans. You can easily set the visibility of different model, different scans. For here, I just show the scans in May. And you will find it easier if you use a section box. To check the to check if it is correct. And you can also see the information associated in each element. So you can find the information, the associated information here, the construction status. And then we go for another elements, which is more clear. If we go to go ahead this of scans in May, and we go to the scan in June, we can see these elements. For example, we go here, we can find the status is right and the scan date is here, right? So we find because it is right and is undetected on the June 28 scans, but the data, the date to the schedule finish date is before the scan date. So this is why we mark it in red. And there's no any elements, constructed elements here. Yeah, I think that's all, a simple demo of what we are doing, how we test it in a screen mode visualization method. And Vito will introduce the AR application on set, which Vito already went to the set and to do the testing.
Thank you, yeah. Yes, so right now I'll cover the augmented reality interface. The same functionalities that Ya has just shown in the browser application. We also tested the same functionalities in the mixed reality. So on the HoloLenses device, as well as in augmented reality. This is the kind of terminology of Trimble, because we didn't develop within Buildspace a dedicated application to browse this information, but we're using commercially available applications to kind of see the results of those algorithms. And we have carried out tests on site. My apologies that we're not doing it live right now, but it would be a huge challenge to do a demonstration on a live construction site, especially with the connectivity and sharing the view from augmented reality interfaces on a webinar. But yeah, we were able to test those functionalities on site a month ago. And yeah, we can now move to the video. We have a video to kind of show what I have personally gone through to test the viewing of the model and delay elements on site. So yeah, first of all, you of course have to load the digital twin, open the relevant model with the visualization of the delays. Then you have to get, yeah, so first you just get the model that is scaled down, but then you have to get awkwardly close to a QR code to kind of move to the visualization in scale 1:1. And then immediately the elements are with some degree of tolerance surrounding you. And yeah, you can then adjust the transparency, maybe manually try to adjust the location of the elements. Here it's worth mentioning that, well, we are testing a bit later when the data was collected. So normally the point behind this would be to have those red elements, well, still surrounding you once they're not there in reality. But here we, of course, tested and the construction site went on and the delays were simulated. And you were able to click into the element and check their status, read more information about particular elements. So it worked great. And yeah, the HoloLenses are still, I would say, on a more of a experimental side. but this was thanks to also using the commercially available application. It was quite user-friendly, and the information was clear to find. Yeah, so that's pretty much the summary of the tests on site. Thank you.
We can see there's a raised hand. Do we take questions from here?
Yes, for sure, we can do it now. Maybe Piotr, we're gonna give you the access to talk. You can also turn on your camera if you'd like to, and let the partners to know your question, please. I think you should have the access now. You can turn on your camera and your mic if you would like to ask the question directly.
Maybe we go for the demo for service 2 first.
Yeah, and then we can come back to this. Thank you, yeah.
I will stop sharing now.
Okay, thanks, yeah. So now you should be able to be watching my screen. Okay, so regarding the service 2, we'll be able to take a look into the core functionalities of the platform and then the output generated regarding the Barso pilot. So, okay, now, right. So we start the video. So this would be the landing page, which serves as the entry point for both services, either service 1 and 2. And it includes a brief description of each service functionalities and objectives regarding either the technical details or the output. Then in the top part, we have a header including a brief description of the development of the platform by the UPM, then some contact emails in case you may find any issues. And then we also have a user guide developed for including the different functionalities and how to use them. And a button that allows us to go back to this place in case we are diving into the different viewers and we want to get back and change the pilot. So this first page serves as the entry point, and it's to the GeoPortal, which is completely interactive, and the user may move along it, check the different pilots available across Europe, and then zoom out, refocus the view, and head onto the pilot he has chosen. So here we have the Barso pilot with a brief description of the characteristics of the building. And then if we head onto the service 2, we will be able to get to see the 3D viewer with the building's output, either the RGB, the thermal, and the inner cloud from an interactive way. So this is the model generated with all the information in RGB. And in the top part, we have a synthetic toolbar. In the left side, we have a project tree with all the different layers. And on the right side, we can change the layer that we are viewing, from RGB to classification to thermal to anomalies detection. That would be RGB, temperature, classification, and anomalies. So starting with the toolbar, this button allows us to hide all the other items from the interface. And then the first block allows us to make different measurements and annotations, like knowing a point coordinates, a distance, the height in between 2 points. and also measure the area from a polygon, as it is the case, or the volume within a cube that we may be able to edit as we want. Then also it is possible to make a profile real quick that we may adapt with the desired width, and then easily get to see how the building inside seen, and gain information for each point within the point cloud, as we may see in the left panel. Then the next block, it's about different movement modes within user-based view, object-based view, and helicopter view. Then we may be able to center the view on the whole building. Different predefined views from top to left, right, and so on. And then we have two different projection modes. This one is the perspective one. And the other one would be the parallel one, which requires the disabling the world. So we get to see this warning, just letting us know that it is not able to visualize the Earth in a parallel projection. So we get to these two different view modes. And finally, within the toolbar, we are also able to make sections of the building and get to see either the inside of the section or the outside of the section. This would be the inside. And in the same way, just swapping our button, we are able to see the outside. So we get to focus on just the part we are willing to see. And maybe if you want to get into the inside, this is the way to get to watch it. We are also able to make the section from a polygon instead of a volume. So we are, well, the same functionality, but just defining a custom polygon. So following with the project tree, which is on the left, we are able to, first of all, custom the appearance of the interface. First of all, it is the point budget, which is the amount of points displayed. Then the field of view of the interface and the movement speed. Then the user is also able to turn on and off the shading, and also customize the appearance of the shading algorithm for visualization cases. And also the user may be able to turn off the background and choose between different modes. Then if we head on to the measurements one, we are able to see all the information regarding this annotation that have already been done, either the spatial placing or the temperature information of the point, the classification, and so on. Then along the section, we are able to visualize the semantic information within the whole point cloud and turn on and on for visualization purposes of the different elements of the point cloud. So there are a few predefined views, and then the user is able to turn on and off at his will the different layers. So here we are just turning off the different floors of the inside. Finally, there's a drawer regarding the thermal anomalies legend and information that we will dive onto after we review the different visualization modes. which are the RGB one, which is the first one we were watching, then the thermal information layer. Also regarding the different capture times, as it is quite a big building, and we faced some struggles. The whole envelope has not been captured at the same moment of the day, but along a few hours. So the thermal information may vary in between the different facades. Then we are also able to get to know the temperature value of each point, in this case, -2 °C. And then we also have the semantic classification model we were saying previously, and then the thermal anomalies detection. These anomalies detection are color coded regarding their characteristics as shows the legend, and then also we can get to use the different annotation reports for each of the facades and the solar panels. So just clicking on each annotation, we may center the view on the corresponding facade. And then if we want to get access to the report, just click on the PDF sign. So this would be the thermal anomaly report for the south facade. And as we were saying previously in the methodology, we get to see the general view, the detailed view of the building in RGB, in thermal images, and then the anomalies detected with a different color coding. Then we get to see each section of the building and the different insights from the thermal anomaly detection, either the mean temperature, the anomaly temperature, and the estimated deviation. So if we get back to the 3D model, we are also able to head onto the solar panels anomaly detection, getting to see the different solar panels that the thermal anomaly phase showed with an anomaly or a malfunctioning issue. And the same way we get to see the thermal anomaly report with the RGB, the thermal, and the detection layer, and as well some insights and brief descriptions on the different concepts. Additionally, once the thermal anomalies have been detected, the user is also able to get to see a catalog describing the different types of thermal bridges, moistures, and so on. So as to get a brief information about all this. And if I'm not wrong, we can turn that off, and that be all the overview about the core components of the Service 2 platform. And then if we just want to head back onto the landing page, we just need to click on the map, and that we will be back here so as to check another pilot. And that be all. Thank you so much. So if you want to, I think it's Lisette, you are the one speaking now. So I'll stop sharing.
Perfect. Thank you very much, Ruben, yeah, and Vito for your contributions and for taking us through the all services and the functionalities and the different characteristics that we can find within each of them. Now we're going to open the floor for the question and answers. This section is specifically designed or here to answer any curiosity that the participants may have. And also, of course, to complement the information that it was given during the webinar. So I'll open the floor to this. Please, to the participants, you can write your questions in the chat and we can read them for you. Otherwise, you can also raise your hand and we can give you the floor so you can explain better your ideas. While we give this time, maybe we have a couple of questions for the service providers and for the pilot as well, that maybe can help to complement the information you gave today, and also to answer some of the curiosities that participants have. So regarding the services, and this will go specifically for Ya and for Ruben, maybe Ya can start with the answer for service 1 and Ruben can complement it with the answer of service 2. But the question says, from a practical point of view, how easy is it to actually use these services? Like, would someone without a strong technical background, say a staff member from a municipality or from a construction site, be able to use them, or do you need a specific training?
For the service one, as the service replication slide said, yes, we need the well-prepared data and also the training, like how we process the data and also how to visualize it. It is not easy, actually, and it is not the one-click thing for both service one and service two, I think. Yeah. So Ruben, if you want to add some.
Yeah, so from the service 2 side, I'd say that the platform has been developed keeping in mind the ease of use for either a technical user or non-technical. So in that sense, we have seen that the interface is pretty simple, let's say. So they just need to get used to moving in a 3D model and getting used to using the mouse to pan around the whole interface. But apart from that, I'd say it is quite simple to just swap with the right buttons in between the different visualization modes to make a measure or to just turn on the reports and gain access to the PDF. So I think that a non-expert user could easily, in let's say 10 minutes, would get used to the whole service and the product and the core functionalities of the platform.
Thank you very much, Bob. And I think this is something that our participants can tell themselves as well. If you had the chance to go through the links while the service providers were explaining what you're going to find in Service 1 and Service 2, maybe you had the chance to experience this by yourself to know how easy it is to use. Maybe if you may need some kind of knowledge previously, this is your chance to test the service itself. Now let's go to Vital and the experience in Mostovstal. So regarding the experience of the pilots in Warsaw and Poznan, did working with these digital tools actually change the way you manage or monitor the buildings? Or what kind of impact has these tools had in your day-to-day work?
Yeah, so naturally, we are in a research project. So the main, most of the time that we spent in this innovation, we were still developing it. Only for a few months were we able to actually interact with the developed tools. So I can say that, for instance, in Poznan, simply because of the delay and the gap between the data collection and the testing, it didn't really create immediate value on this side. But what definitely was valuable for us was the fact that we decided early on in the project that it was us that we didn't want to outsource the data collection because it's possible. There are companies in Poland, and I can imagine definitely across Europe as well, that will gladly do the data collection for you. But outsourcing will always be more expensive. And for us, it was a great experience and a lesson of how to operate the drones, how to plan drone missions, and those are valuable competencies that are staying in the company. And when it comes to the Warsaw pilot, here we are right now in the handover process. So I believe the results of the thermal inspection are definitely something that is valuable, and we can share this information with the investor to kind of support official documentation as well. But really, in a research project, it was all about the exploration for us, about the data collection experience, and those services we definitely see the potential of using for our next construction sites. But yeah, here, just because of the time that those constructions are already finalizing, the impact wasn't this huge.
Thank you very much, Vital, for your experience. I think it's very enrichful, especially for those who would like to replicate those services in another territories to understand what is your experience as a pilot and also your experience using the services itself. So I think we don't have any more questions. I cannot see any in the chat. So it means that your presentations were very, very complete. So thank you for that. Thank you for taking us in this journey. Now I would like to go to our next session, which is some evaluation of the services and the conclusions. And for this, I kindly ask to all of participants to please give us your feedback regarding the services that you've seen today. We have the first QR code, it's for service one that Ja presented, and then you have the second QR code that is for service two. I kindly ask you to scan these codes. I'm also sending them now to the chat. And I ask you to first go to service one. There are really short questions about the service. And of course, any feedback that you can leave us at this stage would be really useful, not only for the service providers, but also for the whole project to understand the value of the services in a day-to-day basis in terms of construction and urban planning. So the first code we have is for service one, digital twin generation, and the second one is for service two. There are going to be similar questions for both of them. The goal is that we evaluate the features of each in their own form. So if you have a specific feedback for service one, please put your comments at the end of the form. If you have a specific comments about service two, please put these comments at the end of this form. We're going to have 5 minutes to this. As I said, they are very easy questions. Most of them you have to choose an answer. So I think it's going to be very practical, but I really ask you to all our participants today to do it because, as I said, it's very, very important for our project. So we'll give you a few minutes to do it. And we're going to go later with the rest of our webinar. If you have any questions about the form, please also let us know. We're here to help you and to guide you through this evaluation as well. The main thing is to understand what is your perspective regarding the services now that you have gone through a training and had the opportunity to test the service. We want to see how useful is it actually for you. What's your perspective on this service and the other Buildspace services? I know some of you might have gone also through through the other services training, so you know more or less the aims of Buildspace by developing these services at the building level and the city level. So our idea is mainly to gather feedback on this. So we really thank everyone who is doing it. And I'm just gonna wait a couple of minutes more while the rest of the participants finish it. Okay, Mingo, or participants finish answering, maybe we can go to the last part, which would be some conclusions and key takeaways from this training. And for this, I would like to give the floor again to Vital so he can close up this session while finishing, also while waiting for the other partners to finish their evaluation. So Vital, the floor is yours.
Thank you. Just a few sentences. So I know it's summer season, so people who have joined in the event must be true enthusiasts. So thank you very much for your participation and turnout. Just to quickly summarize our experience, we are very proud that we could have build the competences in the modern surveying methods. The drone missions that we planned was the most complicated use case of drones that we ever had. And we are very impressed with the results of both surfaces. The project is still ongoing, so we expect that there might be some minor adjustments, and yeah, we are looking forward to the potential of these services in the future and using it on next projects. And yeah, I believe that it's often an offer that the investors are asking us for some type of scanning or drone mission. So I think the need for services such as the ones that we developed within Buildspace will grow, and it was great that we could have contributed to this within Buildspace. That's it. Thank you.
Thank you very much, Vital, for that and for giving a perfect closure for this training. And I just have to say thank you all for joining us today, to all participants, to this training session on the digital twins generation and enrichment in the Polish pilots. We hope that these presentations and the demonstrations that we have given to you have given you a clear overview of how Service 1 and Service 2 work, and they, above all, can support you in your daily work and can support more energy efficient and climate resilient buildings across Europe. A big thank you for our speakers as well, Vitor, Ruben, and Ya, for sharing your valuable insights and, of course, for your active participation throughout this webinar and training. On behalf of ALDA and the entire Buildspace Consortium, we look forward to keep staying in touch with you and seeing how these tools might support your work in the future. Have a great day and goodbye for now. Thank you, everyone.